Now we will get some information about vector product of vector and its applications. Vector product of two vectors is a vector quantity whose direction can be obtained by right hand thumb rule. So the learning outcomes of this e-content are students capable to explain cross product of vector. They can apply cross product of vector in solving several problems. Now what is cross product or vector product? Consider two vectors A and B making an angle theta with each other. The cross or vector product is given by, that is, vector A cross vector B equal to AB sine theta n cap, where n cap is the unit vector along a direction which is perpendicular to the plane containing A and B. The result of the vector product is a vector. For example, torque is defined as the product of force and moment R. Here we know force is a vector quantity, moment of arm and torque are also vectors. So here, what's the meaning of A cross B? Vector A cross vector B means the vector A is rotated towards vector B and its effect is taken on vector B. Direction can be obtained by right hand thumb rule or screw. If we see the diagram, that is vector A and vector B, if we say the A cross B, then right hand screw rule means when a screw is rotated inward, that gives the direction. So A cross B is emerging out of the plane. Also, if we point the four fingers in the direction of vector A and curl the fingers towards vector B, then the direction of thumb will be the direction of A cross B. Similarly, we can guess the meaning of B cross A. B cross A means the vector B is rotated towards vector A and its effect is taken on vector A. The resultant in this case is emerging out of the plane. One common example to understand cross product of vector is closing and opening of a tap. Now, what are the properties of cross product? First, vector product is a vector. Second, vector product or cross product is not commutative. That is, vector A cross vector B is not equal to vector B cross vector A. The third, the cross product of alike unit vector, that is 0. But the similar if B I cap cross j cap is k cap. J cap cross k cap is I cap and k cap cross I cap is j cap. Similarly, j cap cross I cap is equal to minus k and k cap cross j cap equal to minus I cap cross k cap is equal to minus j cap. If vector A, now the rectangular components ax I cap plus ay j cap plus az k cap and vector B equal to bx I cap plus by j cap plus bz k cap, then vector A cross vector B, we can write in the determinant form as. Now we know how to resolve a determinant. First here, AY, AZ, BY, BZ, I cap minus determinant AX, AZ, BX, BZ, J cap plus AX, AY, BX, BY into K cap. On solving this one, we get the A cross B as AY, BZ minus AZ, BY, I cap minus AX, BZ minus AZ, BX, J cap plus AX, BY minus AY, BX, K cap. And we can find its modulus value as we have discussed earlier. Now some applications of cross product. We have taken here some applications from within our syllabus. That is, one is torque. Torque is R cross F. Area of a parallelogram. The magnitude of the cross product of two vectors equal to the area of the parallelogram formed by those two vectors. For example, here a parallelogram formed by vector A and vector B, so its area will be area of parallelogram OAPB is equal to base into height, and that gives BA sin theta. And we know A cross B is BA sin theta n cap, so magnitude of A cross B is BA sin theta, which is area of parallelogram. The same concept we can use to find area of triangle. The area of triangle formed by vectors vector A and vector B is half the magnitude of their cross product. Similar here, as we discussed in area of parallelogram, the area of triangle OPB is equal to half of OB into PN, and PN is equal to AM. So OB into AM is BA sin theta. So that is half of the magnitude of A cross B. Also, volume of parallelepiped can be found out by using a scalar triple product, which is vector A dot vector B cross C. Some more applications are, first is angular momentum. We know angular momentum vector denoted by vector L equal to R cross P, where R is the position vector of the object and P is the linear momentum. Also, the magnetic force on a moving charge, which is given by F vector equal to Q V cross B. Another applications to find out angular velocity. In a rigid body rotation, linear velocity V is given by omega cross R. And checking for parallel vectors, if A cross B is equal to 0, then vectors are parallel or anti-parallel. That is, angle between them is 0 degree or 180 degree. Thank you.